hierarchy of arguments. So we kind of talked about this throughout the semester. So if you'll recall, an argument consists of two parts. We've got the premises, and I apologize, my pen is being fickle here. And remember, the premises are just the given statements. And then an argument always consists of a conclusion as well, okay? So here's an example of an argument. If I go to the Bahamas, then I go snorkeling. Okay, here's one premise. I go to the Bahamas. Here's my second premise. And then my conclusion, so therefore, if I go to the Bahamas, then I go snorkeling. If I go to the Bahamas, then I go snorkeling, is the conclusion that you can draw from that. Why can I draw a conclusion like that? Because the conclusion follows the set of premises. If you do this, then this is going to happen. I did this, so that's the condition, right, that enables this next thing to happen. This is the consequence of the condition. So since I did this, then that means I had to have done that. So I know that that's a valid argument, okay? And how do I know that? If the conclusion is true whenever the premises are assumed to be true. And it's an invalid argument when it's not valid, which we call a fallacy. Which we talked about in an earlier section. And we looked at different fallacies. So how do we know if an argument's valid? One of the things we can do is we can create a truth table and to test the validity of an argument. Okay, so we're going to do what we've been doing. We're going to use a letter to represent each simple statement in the argument. So like P and Q, we're going to express them symbolically like we've done. We're going to write a symbolic conditional statement in this form here. So we're going to practice doing that. We're going to construct a truth table, and if the final column of the truth table has all true values, the conditional statement is called a tautology. So just remember T for true, T for tautology. It's an easy way to remember it. And that means the argument's valid. If the final column doesn't have all trues, then it's the conditional statement's not a tautology, and the argument is invalid. Okay, so here's an example. You might want to take a minute to pause the video and read this. In an episode of the television series Star Trek, the Starship Enterprise is hit by an ion storm, causing the power to go out. Captain Kirk wonders if Mr. Scott, the engineer, is aware of the problem. Mr. Spock replies, "If Mr. Scott is still with us, the power should be on momentarily." Moments later, the ship's power comes on, and Spock arches his Vulcan brow. "Ah, Mr. Scott is still with us." Spock's logic can be expressed in the form of an argument. So one of the premises is if Mr. Scott is still with us, then the power will come on. And the second premise is the power comes on. The conclusion is therefore Mr. Scott is still with us. So let's determine whether the argument is valid or invalid. Okay, so the first thing we're going to do is define P and Q. So P is just Mr. Scott is still with us. And Q would be the power will come on. So if I translate this to symbols, it looks something like this. If P, then Q, okay, the power comes on, so Q, therefore Mr. Scott is still with us, P. Okay, I'm going to translate that now to this. So this is going to turn into if P then Q. Okay, so I'm going to take my original P and Q and write it as a conditional, and then I'm going to connect it to Q, so and Q, and then if P. Okay, so you take this part here and then this part here and make them an and then you would write your consequent, which is the conclusion in this case. So now we're going to make a truth table and see if we get all truths for this column. So again, you need a P and a Q column, okay, and we've done this enough times to know it looks something like this. Okay, I need a column for everything, so I need a column for if P then Q. And remember that that's going to be true everywhere except true, false. Okay. Now I need a column for this because I already have a column for if P then Q and I've got a column for Q. So now I'm just going to put it together. So you need a column like that. So now remember, I'm going to read it backwards. I'm going to go this way. So from here to here, and it's an and. Okay, actually it doesn't even really matter because an and, remember, needs to both be true for it to be true. The only places that it's true is here and here. So there it's false and there it's going to be false because of that one false right there. An and is true only when both are true. So it's going to go true, false, true, false. Okay, now I'm going to put everything together and make my final column like this. So I'm just going to rewrite that now. Okay, so now it's an if then, and you want to be careful. You're going to read this part first. So that's this column here, and then that's the consequent, right? It's if this, then that. So you have to go from here to back to this first column, but you're going to go in this direction here. Okay, so remember it's an if then. When is an if then false? When it says true, false. So here it goes true, true. So that's true. False, true is true. Here it's true, false. So that means that that's going to give me a false, right? And then it goes false, false, which is true. So it's true, true, false, true. Now, that last column is my answer column, and I don't have all truths. So that tells me that this is not a tautology, which also tells me that this is an invalid argument. Why is it invalid? Well, it says, if Mr. Scott is still with us, then the power will come on. The power comes on. Therefore, Mr. Scott is still with us. Well, in order for this to happen, this has to happen first. So it's kind of like, counting your chickens before they hatch, or the expression putting the cart before the horse. This happened before that actually happened. It's kind of like in that first example, if I said to you, if I go to the Bahamas, then I go snorkeling. Let's say I change this premise to I go snorkeling. Therefore, I go to the Bahamas. That's not a valid argument, right? You can go snorkeling anywhere. It doesn't mean you went snorkeling in the Bahamas. So the same thing here. The power could have come on for any reason. It doesn't mean Mr. Scott is still with us. If we changed it to, if Mr. Scott is still with us, then the power will come on. Mr. Scott is still with us. Well, then therefore we can assume the power comes on, but that doesn't happen. The power comes on first. You can't just say, well, then Mr. Scott is with us. This has to happen before that happens. So P must occur before Q must occur. That's the whole purpose of a conditional statement. Okay, so what you're going to do here is you're going to do the same thing. You're going to take the symbolic statement and translate it to something like this, okay? Then you're going to create a truth table for it. And remember, all you're doing is you're taking this here, right? and you're taking this here and turning them into an and then you're writing an if then, and then that's your conclusion. Okay, let's talk about sound arguments. What is a sound argument? So sound arguments are valid arguments with true premises. Here's some examples of standard forms of arguments. Some of them are not sound, okay? We have 4 types of valid arguments. We've got direct reasoning, which was the first example I gave you. That was a valid argument. If I go to the Bahamas, then I go snorkeling. I go to the Bahamas, therefore I go snorkeling. Since the contrapositive is logically equivalent to the original conditional statement, of course, this argument form is going to be valid as well. Okay, we call it contrapositive reasoning. Disjunctive reasoning is a valid argument, P or Q, not P, therefore Q, or P or Q, not Q, therefore P, because it's an or, right? So only one of them has to be true for the overall statement to be true. So if P doesn't occur, then that means Q occurs. And if Q does not occur, that means P occurs. And then you have what's called transitive reasoning. If P, then Q. If Q, then R. Therefore, if P, then R. Or if not R, then not P. For invalid arguments, you've got 4. You've got what's called the fallacy of the converse. And if you notice, it takes the form of the converse. If Q, then P. So that's an example of the Mr. Spock example. That was a fallacy of a converse. It was an invalid argument because this happened before that happened. You got the fallacy of the inverse, which if you look at it, it goes in the form of the inverse. If not P, then not Q, right? And again, the converse and inverse are logically equivalent. So it makes sense if this is a fallacy, then that's a fallacy. You can have the misuse of disjunctive reasoning. So this says P or Q, P, therefore not Q. Well, remember, we're talking about an inclusive or, right? Which just means one or both can occur. So just because P happens doesn't mean Q won't happen. Q could also happen, right? And then here's another example of the misuse of disjunctive reasoning. And then you have the misuse of transitive reasoning. This says if P then Q, if Q then R, therefore if R then P, right? And that's not necessarily true. This has to happen before that happens, okay? So have this chart handy. You'll need it, to be able to refer to the different examples and figure out if the arguments are valid or if they are invalid. Okay. So let's look at an example or 3 here where you've got to figure out whether or not the arguments are valid or not. Okay. So in this first problem, what we need to do is determine whether each argument is valid or invalid and identify any sound arguments. So in this first example, it says, there is no need for surgery. I know this because if there is a tumor, then there is a need for surgery, but there is no tumor. So let's first define our variables, okay? It's talking about surgery and tumors, so we know we've got 2 statements. The first is there is a tumor, okay, so that's going to be P. And then Q is there is a need for surgery. And notice I'm writing these in the positive form, which you always want to do. Even though there's some negatives in there, you always define them in the positive. Okay, when you translate, that's where the negative comes in. So now when I translate this, right, it's going to be something like if P, then Q. If there's a tumor, then there's a need for surgery, right? So that's the part I just defined. But there is no tumor, so that's going to be not P. Therefore, right, there is no need for surgery, so not Q. So my conclusion actually came at the end, right? Or at the beginning, rather. There is no need for surgery. That's what they concluded based off of the statements that made. What are the statements? The statements are, I know this because if there is a tumor, then there is a need for surgery. So that's a premise. It's a statement. It's like a evidence, but there is no tumor, okay? So if you take a look at this and compare it to this, it's the same. So it's an invalid argument, and it's the fallacy of the inverse. And that also means it's not a valid argument. Sorry, a sound argument. Okay, let's take a look at the next one. The emergence of democracy as a cause for hope or environmental problems will overshadow any promise of a bright future. Because environmental problems will overshadow any promise of a bright future, it follows that the emergence of democracy is not a cause for hope. Okay, so first I need to define P, which would just be in that first statement there. The emergence of democracy is a cause for hope. And I'm going to just abbreviate there. Okay. Q is going to be, let's see, or environmental problems will overshadow. So it's after the word or, it's going to be environmental problems. And then we know will overshadow any promise of bright future. So again, I'm just going to abbreviate. Okay, so let's translate this to symbols first. So the emergence of democracy is a cause for hope. That's P. And then we've got the word or. Environmental problems will overshadow any promise of a bright future. That's Q. Okay, because environmental problems will overshadow any promise of a bright future. So that's going to be Q. It follows that, so remember that's telling me that's the conclusion. It follows that the emergence of democracy is not a cause for hope. So that would be not P. Okay. Now, if we go back and look, so let's compare this. We've got P or Q, Q, therefore not P. And right there, that's a misuse of disjunctive reasoning. Just because Q didn't happen, just because Q happens doesn't mean P won't happen. So this is, again, an invalid argument. Why I did that. And it's a misuse of disjunctive reasoning. Okay, and it's not sound because sound arguments have to be valid. Okay, if evidence of the defendant's DNA is found at the crime scene, we can connect him with the crime. If we can connect him with the crime, we can have him stand trial. Therefore, if the defendant's DNA is found at the crime scene, we can have him stand trial. Okay, so here we've got three different statements. We've got one of them about the evidence. We've got the other one about the connecting with the crime scene. And then the third one would be about standing trial. Okay, so let's translate it. So if the defendant's DNA is found at the crime scene, so that would be if P, we can connect him with the crime, so then Q. If we can connect him with the crime, so Q, we can have him stand trial, so that would be R. Okay, therefore, if the defendant's DNA is found at the crime scene, so P, then we can have him stand trial. Okay, and we're going to look at this one now and go back. And we can see that this one is okay. It's valid and it is transitive reasoning. So that means it's also a sound argument because the premises appear to be true, right? So this is valid and transitive reasoning. And it's also a sound argument. The last thing we're going to look at, okay, there's problems there for you to try, is logical or valid conclusions, which we kind of already talked about. You just want to remember that they're just conclusions that form a valid argument. When it follows a given set of premises. Okay, so now we're looking at valid conclusions. Okay, so here's another premise. We want to draw a valid conclusion from it. So in the past, they gave us the conclusion. We had to determine whether it was valid. Now we're going to draw a valid conclusion. If all students get requirements out of the way early, then no students take required courses in their last semester. Some students take required courses in their last semester. Okay, so let's define first. So we've got P, so that would be after the word if, all students get requirements out of the way, right? And then Q is students take required courses. Sorry, no students take required courses their last semester. Okay. So if I convert this now, it's if all students get requirements out of the way, then no students take required courses. And remember, no students is not a negation. It's just, if you wanted to negate that, you would say students are not taking required courses, right? Like you would attach the not to the verb. So this is still in the positive. So if P, then Q, and then it says, let's see, some students take required courses in their last semester. So that would mean not everyone does. So not everyone. So that would be not Q. Okay, therefore, what would be my conclusion from that? Well, if P, then Q, not Q, therefore not P, right? Like if Q doesn't happen, then P didn't happen. So that would just tell me that not all students get the requirements out of the way early. And you can check this with this here. It's just the contrapositive reasoning, which is a valid argument. Okay. So that is the end of this section. If you have any questions, please feel free to reach out. Make sure you try those problems that I left for you all. They're really good practice. But again, if you have questions, feel free to reach out to me.